All right, so let's talk about exponential functions. An exponential function, and we use these guys, you probably, well, they're used more often than you think. Exponential functions will look like this, a to the x. The odd thing about this, not really odd, it's the placement of your variable. So with all the stuff that we did for the last test, our variables were the bases. We had x to the fifth power, x to the fourth, x to the third. Here, x is not your base. Your base is going to stay constant. It's the power that's going to be changing. Your base is going to be a value that's greater than 0, but we're not going to be looking at the base being equal to 1, because if the base equals 1, it's a constant function and it's not exponential. And let's talk about what this means right here. A to the x is a unique number for every real number that you plug into it for the x. Okay? And since it's going to be unique, that means that a to the x is going to be a one-to-one function. And if it is a one-to-one function, that means when you graph it, it's going to pass what?
It's going to pass the horizontal line test.
It's going to pass the horizontal line test. And if it's a one-to-one function, that means that it has a what? What? Say louder. An inverse, right? And its inverse is super, you know what? Its inverse is okay. I don't want to get you too hyped for it and then be disappointed later. The other neat thing about this, and this is where we have a lot of fun, and this is where your next test can be super easy, is if you guys know how to work with powers and how to solve linear equations, you're going to like this next test. If you don't understand how powers work, you're going to be wrecked. That's R-E-K-T, wrecked. And what I mean by that is, like, do you know 36? The number 36 is 6 to what power?
6 to the 6th power.
As long as you know that 36 is 6 squared, we're going to be fine. If you think that 36 is 6 to the 6th, as they would say, bye, Felicia.
Large cultural lexicon. What does that mean?
I don't know. I've just heard that means something like, get out of here. I bet the person's probably going to catch you outside. See you at the races. Any other weird phrases you guys might say. They're probably going to be keeping it hundo P. So when you... That's another edit that's not going to happen.
Are you cropping that too?
Am I what?
Cropping that?
I'm not going to crop anything. I'm not going to cut anything out. Is that what you want? You want me to be filtered? Maybe that's what you would want. I'm not good enough in my normal state. I got to be who you want me to be. So anyway, this is a super cool expression. And what it means is that as long as these guys are the same base, if you have the same base, the only way that these expressions can be the same is if their powers are also the same. You know what? I'm so excited. I got to show you what I mean by that. It's so cool. So that means we can talk about solving equations that contain exponentials. So if I ask you to solve 5 to the x equal to 125. Did I give you guys a sheet with powers on it at the beginning of the semester? Mm-hmm. I did? Yeah, you might want to find that again. Maybe some of you laminated it because you were forward thinking. Or maybe you have it in your iPhone case because you know how cool it is.
It's in a landfill right now, probably.
That's no good. You should have at least recycled it. So here, can you write these so they have the same base?
Yes.
Yes, because 125 is 5 to the what? It's 5 to the third. And since these guys have the same base, the conclusion, because we have this one-to-one function, the conclusion here is that the powers must also be the same. So x equals 3. Is that cool? That's right. Mind equals blown. Just make sure to clean up after yourself.
Oh, I don't have a mind to control that function.
Oh, dearie me. Well, we should be like that Pokemon, Mr. Mind.
Mr. Mind?
Yeah, Mr. Mind. It's a Pokemon, right?
I think you sound like a 4-year-old who's trying to pronounce the Pokemon names but can't exactly get it the right way. Mr. Mind.
Pikachu, bless you. So 4 and 8 have a common base of what? 2, right? So here's what you're going to do. I'm going to rewrite 4 as 2 to the second power. But then that's still raised to the x, right? On the other side, 8 can be rewritten as 2 to the what power? 2 to the third, and that's raised to the x plus 5. You also have to know how to work with properties of exponents to be successful in this next test. Here you have powers to powers. Right? So what do I do when I have powers to powers? Add them? I disagree. When a power is raised to a power, you multiply those guys. So this becomes 2 raised to the 2x is equal to 2 raised to the 3x plus 15. Right? And now, again, since these guys have the same base, what can I then conclude from this?
2x equals 3x plus 15.
Right, so as long as these guys have the same base, you can just take those powers and set them equal to each other, and now you have a nice linear equation. If you can't solve this, much sadness for you. The weeping and gnashing of teeth. How do you solve this?
You subtract 2x and then subtract 15, you get x equals
Yeah, you can do that. I don't like leaving one side empty. And you can do that. I'm not saying that's wrong. I'm saying what I would prefer to do is to move the 3x to the other side. So then negative x is equal to 15, which means that x equals what? X equals negative 15. And so that's the solution for this equation. So that's what we're going to be looking at a lot in the future, is taking these expressions, making sure we can get them to be the same base. And once we have the same base, that means these powers have to then be the same, and that's the equation that you then solve.